if you split our thought process into two pieces, right, there are a bunch of Python related tools. And here I'm not stressing the basic Python syntax, right? What is a variable? What's a function? We will cover that as we go and use it as we need. I'm going to start introducing you to some bigger ideas in programming. Okay, and today, for example, we'll explore some ideas in this very interesting programming style called functional programming. Okay, but we will cover some functional programming. We'll talk about data a lot, but data has to be organized, and we in computer science organize data into data structures. So we'll talk a little bit about data structures and really understand how when you put structure into data, we can start solving problems. So for those of you who are saying we want to do data science, it's already very interesting that if you can put data into good structures, many problems already get solved, right? So that's very helpful. Then once you have functional programming and data structures together, now we have to come up with some good ideas about how to do things. So we need algorithms, right? So we'll discuss how can we create algorithms or what existing algorithms are there. Clearly, the field of algorithms and data structures, they're very big topics. You can do like 1 year course or 2 semesters or 3 semesters of study into these. So my goal is to, make you interested and give you some flavor of this. And then we can discuss whether you want to study it more or not. But at least we should be comfortable writing some algorithm, analyzing an algorithm, etc. And then the last thing is, of course, to write machine learning programs and just to be a programmer in general. There are a lot of programmers, idioms, and design patterns and things that people use. As soon as they see a problem, they know how to solve it, what kind of code to write. So we will explore some of that. And there are some Python specific things in here as well. So if you come from different programming backgrounds, I will translate them. These are all kind of tools that we have. Now we should apply them, right? So I want to apply them to fields like, maybe we'll do a little exercise in cryptography. I will show you today some basic mathematical things. I want to stress this idea that mathematics is not something that's difficult or hard or intimidating. Should not be. So if you have had some tough experiences with mathematics, we'll leave them outside. But more importantly, the reason why I include some mathematical stuff into this discussion is for 2 reasons. Number one, it actually gives us very clean examples, right? So for example, if I want to show you how a particular programming operation works, I can use addition as an example. It's very clean and simple. Everybody knows 1 + 1 is 2. So addition is mathematics, but addition is also a very nice way to think about, in a pure way, about how we structure our thinking, etc. Okay, so mathematics, we'll do some algorithms. We already did in a previous course some graphics and games. Maybe we'll do a little bit more. I think the graphics and games gives us a large enough program in which we can test our understanding, right? So we'll do a little bit of that. And the last one I thought which would be cool for this course is, I want to show you how when we have a powerful computer and programming tools at hand, if I ask you some difficult questions, we can actually solve them by asking the computer to find the answer. As soon as we know how to ask the computer to find the answer, then we're going to be able to read off the answer from the computer, which is kind of cool. Okay, so but we have to have the skill to translate the problem into something that the computer can generate for us. Okay. Okay, if that sounds abstract, let me give you an example. And maybe you can tell me if this is interesting to you. So there's a very famous problem in, which was a game show, right? There are 3 doors, and behind 2 of the doors, there's an animal. Pick your favorite animal, a monkey or dog or something. And behind the 3rd door is a very valuable thing, like a pot of gold or a car or something, keys to a house, okay? So you walk into the game show and you ask to pick one of the doors. So let's say you pick door 1. Now the person who's in charge of the show, he knows where the gold is. So he opens another door and he shows you the monkey, right? He says, here's the monkey. So now the question to you is, should you stick with your original choice or should you flip your choice? Because there's only 2 doors left, yes? Okay, so what do we think the answer is? Should you stick with your original choice or should you flip your choice?
You can unmute yourself.
Yeah.
Which door was the original door?
Let's say the doors are labeled 1, 2, 3, yeah? And there's some random assignment of two of them have monkeys and one has gold behind it. We don't know where they are.
So Cassandra has answer on flip choice, she says on the
Okay.
chat.
We'll discuss why we should flip.
Yeah, we'll ask her.
Yeah. So, but let me just answer Kiran. So those are 1, 2, 3. You pick door 1. The host, let's say we know the answer for now, just for example. So the first 2 doors have monkeys behind them, and the third door has the gold. Usually you don't know the answer, but for us to discuss, I'm saying, suppose this was the configuration. So you pick the first door, then the person who knows the configuration says, okay, I'll open door 2 and show you there's a monkey behind door 2, right? So now should you flip from door 1 or you should stay in door 1? Of course, because you know that the gold is in door 3, you're going to flip. But you could have as well picked door 3, right? So I want to show you that flipping doesn't always guarantee you win. If you had picked door 3 and you opened door 2 and showed you a monkey, if you flip now, you will get a monkey, not the gold. You chose right and you go to the wrong place, right? So should you flip or should you stay? Or it doesn't matter?
I think it doesn't matter really.
Okay.
Because it's 50% chances of winning if you flip and 50% chances of losing if you flip.
Okay, yes, Ashish?
So I was going with the same thing. Like earlier, your probability of winning was 1/3. Now your probability of winning is like 50% became. So it's like probability is higher. So it's not going to be guaranteed even if you flip or you don't flip.
So I'm going to share and I'm going to ask Cassandra, but we won't solve this problem today. But I want to say that this is a very confusing problem. Very confusing, not because the math is hard or anything. For human beings, it's very hard to understand this problem. Okay, and I'll tell you the answer. The answer is what Cassandra said. You should flip.
But let's say, Cassandra, what's your reasoning?
Yeah, why?
Honestly, I'm relying on my memory of the answer, and not so much. I think I tried to understand it once, and I think I ended up understanding it by probability, but it was still like hard to get my head around it. But I know that's the answer.
Yeah. So the point is, there's a way to calculate this using probability, right? But even if you calculate using probability, you'll make your head hurt. So anyway, I'll show you how to do it using probability. But what is very interesting is we can tell the computer, hey, generate 1,000 configurations, right? And in each configuration, you choose one door and then you flip and you don't flip and you see whether you win or you lose or what happens, right? You can actually keep on repeating this experiment. And then you can say, what are the odds? Is it better if I flip or not? You see what I mean, right? You can actually simulate the situation. And now you can say, okay, I understand. Right? I have looked at 1,000 examples and now I understand that switching is better or staying is better or whatever.
I think one can reason it out by probably saying that when you started, like it was equal probability 1/3, right? And when the guy opened the door, he is dramatizing, so he will not going to open the door where there's a gold is, right? So now he opened a door where he knows there's a monkey. Now he made it 2. So now the probability is half. So now you want to switch it to the door where the probability is half versus being 1/3 when you started with. So now you want to flip to improve your probability. But I think you can use Bayes' theorem to prove it.
All these theorems doesn't matter. Like Cassandra said, whatever explanation I give you, you're going to still feel a little bit like
confused. Yeah. So you need to have like rigorous proof is using Bayes' theorem. You can do that conditional probability.
Yes. So we can discuss briefly, right? So there's some statistics and probability, but I want to show you these are all the kind of ingredients that go into like data science.